going up to 200 bar. However, in mobility applications, or at applications at 700 bar, they would get too heavy. We would entirely ditch the advantage of hydrogen being so light, so we need to find other solutions. And that's where the different types of cylinders come into play. We have just seen this one here, the type 1, the all-steel cylinder. Now, to make this lighter, we can reduce the thickness of the wall and make a hood wrap out of composite. Then the next evolution step with the type 3 cylinder, you essentially have a metallic bubble, and then you wrap carbon fiber or glass fiber around this metallic bubble. The metallic liner is for the leak tightness, and the composite is taking the entire stress of the pressure inside. The last step is ditch the metallic liner, take a plastic liner. Well, we use traditionally high-density polyethylene and polyamide. And that's how we save that's why we are at 20 to 25% of weight at a steel cylinder, with being even better if we are looking at high pressure applications where you cannot even use a steel cylinder anymore. Top left, traditional steel cylinder. Top right, this type 2-1, a steel cylinder just wrapped with composite around the cylinder area, because this is the weakest one in a cylinder. This one here is the metallic bubble of the type 3 cylinder, and that's the finished cylinder. And this is our solution, essentially a plastic bubble, and then the carbon fiber is wrapped around that. Here you can see a cut section with the plastic liner inside and the metallic bosses on the side. So first, you have to get this liner. How do you do that? In the past, always via blow molding. So essentially, you have a tube of plastic, put it in the mold, and then you apply pressure so this plastic tube expands and forms the final liner. Then you would screw on those metallic bosses. But this technology has a disadvantage. So you're limited, you have to create large molds, and you're limited actually in the total length and size of those liners, because at some point you cannot produce those molds anymore. So therefore, a three-piece design is now being deployed. You have a traditional plastic tube, and then you take those metallic bosses here and do injection molding around those to form those domes. And then you take those domes, you take the plastic tube, and you can just weld it on. So essentially, you have a large metallic plate, which is hot. You drive the dome on one side, you drive the tube on the other side, attach it, it gets hot, you remove it, and then you weld it on. And this allows manufacturers or us to also change the size of the cylinder or the length of the cylinder without creating a new mold. Then ultimately, after these bosses have been attached or being injected into that, the liner is put on the winding machine where it turns, and then the carbon fiber is being attached. First use, of course, always in the defense industry. And with the high-density polyethylene, this technology started in the 90s, and now we're moving from polyethylene to polyamide, because this provides a better permeation of hydrogen, so the tanks are tighter, lower leak tightness at high pressures. You can see those plastic liners with the bosses being injected and the finished cylinder. Now, what can we apply compressed hydrogen nowadays? So that's why I quickly jump into our company. We are dedicated to zero emission mobility. And we're starting off after the energy source with the energy storage. So we're producing battery systems, but we are mainly focused on hydrogen cylinders and systems in order to apply those, for instance, in the heavy duty business, in the maritime business, trains, buses, and so on. So we produce those Type 4 cylinders. This is our main product, this is our main core technology, and we sell those cylinders to our customers. However, we have also evolved since then because it's not quite sufficient anymore just to throw out a cylinder to the market. So therefore, we put them into systems. So we combine piping and valves and all of that stuff and control software, and then you can attach those systems on top of a bus or in a train in order to run this with hydrogen. And lastly, we have certain distribution modules. So you pile up all those cylinders within a container in order to transport or to store hydrogen. Typical customers are large chemical plants or producers such as Linde or Air Liquide that need to deploy hydrogen to their different sites. For comparison, I believe Mirko just talked about their 20-foot solution, storing, I believe, 250 kilograms of hydrogen. We are now here, and I'm actually quite surprised, at a 20-foot container at 600 kilograms of hydrogen. So running here at 1,200 to 1,300 kilograms of hydrogen in one container. But probably technology will also evolve in metal hydrates, because in theory this should have a higher density. The truth is also we cannot transport more hydrogen than a bit more than a ton on a truck, because we're already reaching the limits of the 40-kilogram truck. So now the work is not in optimizing the cylinders, it's actually doing lightweight constructions then on this container. So in short, this Type 4 cylinder is the key for the core technology to be distributed in all those different applications. Sorry about that. And if we're looking at the market capability, today distribution business is running quite well. That's growing fast, as well as the transit applications. And for the future, we do see passenger cars, not really, but especially for trucks and mobile refueling and trains. This is the business of refueling stations at their sites, trains with hydrogen. The first hydrogen trains in Germany are also currently being deployed and being tested. There has been some negative press because of some quality issues, but that is life, I believe. And Nikola is also starting up their new plant in Ulm in cooperation with Iveco here in Germany. So if you ask us about the long term, the truth is battery will make the business in the part. But we believe compressed hydrogen will stay competitive for a very long time in the mid and heavy duty business, because the ranges of a hydrogen truck is twice as much as a battery truck, whilst having the battery at 5.5 tons and having a hydrogen system weighing 1.5 tons. So an advantage of 4 tons